introduction for me, but I think you already know me. I'm just quickly going through that because I don't have enough time, I guess. As you know, I'm an academic at Swinburne, and my research area is mostly about intelligent human-robot collaboration and assistant robots for helping patients and elderly care. I also work in the domain of electricity price forecasting, energy domain, and optimization, also for computer vision, human pose estimation, and action recognition. These are the applications that I already did some research on that. So if you are interested in having collaborations, I'm happy to be connected after the talk. I'm also a superstar of STEM, which is a recognition in Australia to give high-profile women in STEM more visibility by media and public talks. And they are trying to give courage to female students to enter the STEM field more than before. Actually, it has been very successful, this program. So just before going through the more topics in AI that I'm talking about, let me just clarify some terms in artificial intelligence domain. So basically, this figure shows the difference between those. Artificial intelligence is algorithms, as you can see here, that we have the programs that mimic ability of learning of human, so it mimics the human behavior, but it doesn't necessarily need to be machine learning. It can be rule-based programs as well. So basically, machine learning is a subset of artificial intelligence that doesn't need explicit programming for finding the patterns in data. And when we say deep learning, it means subset of machine learning algorithms that's based on neural networks, and basically we fit through lots of data, and it can actually come up with features of data itself without knowing anything about the feature engineering or feature extraction things. And that's the beauty of deep learning over machine learning as well. Yeah, I'm quickly going through the popular machine learning algorithm types to get through the most recent one, which is self-supervised learning. So as you can see here, these are the three traditional machine learning algorithms: supervised learning, unsupervised learning, and reinforcement learning. The difference between them, in the simple word, is in supervised learning, we have data and labels. So it means that the system can find the similarities between data and then double check it with the ground truths that we provide, and then come up with a solution for the problems, and can actually repeat it for similar problems with the new data sets. For unsupervised learning, we provide the data, but we don't provide any labels. And still, the machine can actually come up with some patterns, some similar patterns, and can cluster based on those similarities between the data, and also based on the differences between the different clusters. For reinforcement learning, it's even worse. We don't have data as well, so we just start with minor data, and then as we go through the experience, we are completing data set, and based on the reward and penalty that system receives, it can decide that which direction it goes, continue the way that it actually already went, or like changing it, upgrading it to a new direction. So this one, the self-supervised learning, basically is the most recent technique that's taken over the world. So it's a set of techniques that allows systems to represent data without requiring labeled data, or without like any manual intervention from human to produce the data. Another way that I can explain it is like a machine learning technique that use unsupervised learning for some tasks that conventionally need supervised learning. So rather than relying on labeled data sets for supervisory signals, self-supervised learning models generate labels from the unstructured data itself. And it's pretty much the way that all the NLP neural networks, all the NLP tasks that are based on neural networks are working these days. So to apply it in a simple word, what you need to do is just take a piece of text and then like a sequence of words, and then you corrupt the input, the original input, by masking some of the words, and then give it to the neural network and ask to reconstruct the original input. So what happens is, through this process, neural networks is coming up with a representation of that masked words, and it can actually recover those masked words for you. Then we can use that representation as a pre-trained model for the subsequent tasks, for any task like question answering or like translation or anything. So that's basically the fundamental theory of self-supervised learning. And you know that for NLP tasks, we can't use words, we need subwords or tokens. So we need to separate like the prefix, root, and suffix, and then give it to the machine to come up with a solution for that. So here I'm going to quickly show you the two models that are popular in this domain. So basically, the BERT model was the first one which was very successful for many tasks. This is the stack of encoder blocks. The input text is separated into tokens, as I said, and each token will be transformed into a vector at the output of the BERT. So BERT model is trained using masked language model, or MLM, as you can see in the figure, and next sentence prediction. So here, what you need to do is only text, not labels. And because it works based on self-supervised learning, as I explained, it just come up with the representation itself, the internal representation, and then using that internal representation, you can actually complete the subsequent tasks that can be anything like summarization or translation. In the transformer model that you can see here, it's a bit different because it's integrated the encoder and decoder together in one structure. So they are connected to make a sequence-to-sequence model with an integrated attention mechanism, in order to basically perform a translation or other tasks, other NLP tasks. So you can understand it as an oracle that can quickly identify which pieces of text or information that you're giving is more important to pay attention to that. So that's the duty of the attention mechanism. And this equation that you can see here is the equation of attention, and those Q, K, and V are actually embedding vectors that transform by a weight matrix. So basically what transformer model needs to do is finding these weights and matrices. And once the weight matrices are learned, the transformer becomes a language model that then you can use it for any subsequent tasks such as translation and summarization. All right, so now I'm going to talk about the common steps of principles actually behind the generative AI. As you know, generative AI models can actually come up with a class of models designed to generate new data that resembles a given training data set. But the theory behind that is kind of like self-supervised learning that I just explained. You can see the structure now and understand the similarities with that. So basically, the working principle of generative models are very depending on specific type of model that they use, but there are some common steps, as you can see here. So the first one is probabilistic modeling, and the aim of that is to model the probability distribution of the data and generate new samples by sampling from a learned distribution. And the distribution can be different based on the data, if it's discrete or if it's continuous. So the second step that you can see here is latent space representation. So many generative models actually learn a latent space representation, which is a lower dimension representation of training data. And then based on the features that they come up with that in this representation, then the generative model can create new samples based on that. So they use autoencoders usually, and variational autoencoders as a technique behind the scene for that. And the adversarial training is working based on the theory of generative adversarial networks, or GAN, in short form, that works based on two main networks, generator and discriminator. And what it does is generator network tries to generate some fake images, for example, or other inputs, other formal inputs such as voice or music. And then the discriminator network tries to actually differentiate between the generated samples and the real samples. And through the iterations, these two networks are competing together. And based on that, we get through the best representation in the end and more realistic, for example, images in the end, because they are competing with each other to somehow fool each other, right? So that's the main idea of adversarial training. And then the next step is autoregressive modeling. So autoregressive models, such as transformers that I showed you, works based on that simple theory that I explained. So basically, when you remember that I explained that we take the text and corrupt the text by masking some words and then give it to neural networks to reconstruct it, right? So for autoregressive models, what we do is just corrupt the last bit of the text, so just the last word, and then we try to recover it. And we do it, and then we use that generated word in the end with the remaining ones as a new input to the network. And then we repeat it again and again to build our output. So that's called autoregressive models. And then through the reconstruction and error minimization, the models aim to minimize the error between the input and the generated output by encoding data into the latent space and then decoding it back to the original space. So basically, the encoder is the part that come up with the features of the latent representation, and then we use several decoders sometimes for different tasks to decode that samples to actually generate what we want as the subsequent task. And these are some samples of the most popular application for the generative AI, which is image generation. So you can see the DALL-E model by OpenAI in the left-hand side, and then Imagen by Google, and also Meta that created some models, like different models, but the last one is EMU, called EMU, that I'm going to show you how it works. So as you can see, EMU released in 2023, and what it does is you give a prompt to that, and then it come up with generating an image based on your prompt. And then you can actually update it as you go, add some items to that, or add a story, and it will apply it right away and show you a video. So you can see that it starts with like a white bunny, and then it asks to play a trumpet. And then, as you go, it's just completing the story. So you can actually create your animation easily with that. You can come up with like storybook as well. So in terms of AI perception, because it's as you remember, I talked about one of the layers in developing AI, and it was AI perception. So the first stream of AI perception is computer vision. And it basically helps us to do image understanding, object recognition, semantic segmentation, and image reconstruction. So I'm going to show you one of the recent models that called Segment Anything Model, or SAM, from Meta. So you can see that it's prompt-based, and it can actually detect objects. It can segment it based on that, and somehow do all of the tasks in one model. So you can see the structure is based on encoder and several decoder as well, and based on the embedding that I just explained for you. So it has the attention mechanism. I'm going to show you other capabilities of this one. As you can see, it's prompt-based, so you just need to type the object that you want to see, and it's segmented for you right away. The other application that it has is reconstructing the 3D version of the objects, or tracking objects in the video that is based on the same model. The second stream of AI perception is speech recognition and synthesis. So one of the models that recently developed is Whisper by OpenAI that you can see here. And I'm not going to explain it because, it takes time. But basically, what it does is like an encoder-decoder transformer model that you saw before, and the input audio is split into the 30-second chunks and then converted into a log-mel spectrogram and then passed through the encoder. So the decoder duty is basically being trained to predict the corresponding text caption for that. And then intermix it with special tokens that direct the single model to perform tasks such as language identification or phrase level timestamps or multilingual speech transcription. So the second model that I'm showing here is VoiceBox. So this one actually is very useful for different tasks such as style transfer and editing the videos, like denoising videos as well. I'm going to show you a sample quickly.
The country's lush forests and diverse ecosystems.
The quick brown fox jumps over the lazy dog.
The country's lush forests and diverse ecosystems. The quick brown fox jumps over the lazy dog.
So you could see that just with 2-second audio of style, it could come up with converting the content into that desired style.
Hi everyone, thanks for tuning in. Today we are going to show you how to create a beautiful flower arrangement. Hi everyone, thanks for tuning in to create a beautiful flower arrangement. Hi everyone, thanks for tuning in. Today we are going to show you how to create a beautiful flower arrangement.
So you see that it's able to mask that corrupted part and then reconstructed the original text without any noise. The next model is Seamless M4T, which is a multilingual, multimodal AI translation. So it can do speech-to-speech translation, speech-to-text translation, text-to-text translation.
Our goal is to create a more connected world.
Yeah.
Наша цель – создать более связанный мир.
The last one.
Our goal is to create a more connected world.
So you can see that it's working multilingual. So for people who doesn't know that language, they can easily use it.
Our goal is to create a more connected world.
And this is the more normal task, speech recognition, that is come up with the text, listen the audio in any language. Alright, so this is the model that it works based on that, and as you can see, it's also based on the transformer and encoder-decoder structure that somehow has taken over the world. Alright, so now I'm going to shift to the opportunities that AI makes and just touch some examples of different applications for you. So the first one is healthcare that I'm going to talk about. And basically, the first application that I actually worked on is early tumor detection and cancer prognosis. This is one paper that actually they come up with a very good model for DBT, that's work on DBT, digital breast tomosynthesis, and that's a special 3D MRI for 3D mammogram for the breast cancer. And what it does is basically it's poised to take over traditional 2D mammography. And it was recently shown that deep learning can actually achieve good performance in automatically detecting the suspicious lesions in DBT accelerating MRI scans. Another one is, as you can see, fast MRI from Meta, that accelerating MRI scans with AI. So what it does is reduce the time that patients need to spend in the machine, and they always complain about it. And by less data, it can come up with the very accurate result, which is amazing. So the other promising area that we have in biology based on the generative AI is protein folding and protein generation, as you can see here. And basically the most popular model is AlphaFold by DeepMind in this domain. And it was firstly published by Reeves and Jumper in 2019 and 2021. And to give you a bit of background, the protein is a sequence of acids, and we know millions of them. So the idea of pre-trained transformers for proteins first published by these two people, but then it actually gets progressed and come up with advanced models for that. So what they do is taking sequence of amino acids and remove some parts of sequence, as you remember, the corrupting the input, and then train a transformer to predict the missing part. So the theory is exactly the same, but here we are using it for protein. And based on that, actually it can come up with prediction and confirmation of the new protein and how it folds or stick to the other proteins. And it's very useful for discovery of the new drugs that actually can be useful for a new disease or existing disease that doesn't have any treatment. We saw a little bit of that during the COVID-19 for vaccines. All right, so this is also another paper which basically provided a public data set, ESM2, and the good thing about it is you can actually interact with that, add or use some of the proteins over there. So I recommend you to go through that website and check it. All right, now I'm going to talk about the industry applications. As you know, actually AI can be integrated into robotic arms, and these days we are more interested in having assistant robots instead of isolated robots. So AI can help with recognition of the robotic arm and recognition of the human behavior, and based on that, it can act as an intelligent assistant for human to actually complete the tasks, like assembly tasks or any other task in manufacturing. But it's not the only application in industry. So we can use AI for warehouse management as well, and basically it's based on inventory management and AGVs that you can see it's already actually applied from some companies. So basically what it does is facilitating the storage and reaching to the points that it's hard for human, and then it can navigate through the warehouse and make the orders ready for that. And the management, the warehouse management is also including inventory management, which check the storage for the companies, and it can save a lot of money and labor for companies that needs to come up with supply chain solutions. So another area is quality control, which is based on defect detection. You can see this example, and the architecture is very simple based on CNNs actually, but it can detect, as you can see here, the complex types, defect types here in this image, even if it's noisy environment. And it does it based on the YOLO model, which is a deep learning model. So the predictive maintenance is another promising area, and basically what it does is saving money and labor for the company and industry, because they usually have the schedule for maintenance, and now with AI, using AI, it can predict that what's the best time, optimal time for checking that. And before that, you don't need to actually go through repetitive schedule for that. So I'm trying to skip those to help that, but these are the tools that's actually developed for predictive maintenance, and it can show asset details for the different products in the manufacturing industry. All right, so for transportation, perhaps the most popular application of that is autonomous vehicles. And you know already that they are operational in some countries, especially the autonomous taxis. But still, we have a long way to go to make it like more ethical and responsible. So I think in Japan they use drone taxis as well, and in US they use the trucks, which is without any driver. So another one is traffic management, that actually you can use AI for anomaly detection, and based on that you can actually manage the traffic for different roads. Basically, you can detect the illegal parking detection and other anomalies, and then manage the traffic. Also for automated license plate recognition, which is easy. And for road condition monitoring as well, there are some tools that they develop based on AI, and they can actually come up with finding the anomalies through the road and then fix it at no time. All right, so these are other opportunities that AI usually makes. So basically, AI connects people to each other, and the biggest deployment of machine learning today is perhaps the, in social networks, which all hosting companies like Meta, Google, and YouTube or Amazon are built around the deep learning models. So deep learning helps us to handle information deluge by doing things like search, retrieval, question answering, but that requires machine to understand the content. And this will be helpful for people who are not actually literate, for example, or people who are blind or visually impaired. Plus about 3 billion of people are not educated and not using technology these days. So there is other usage of AI these days to filter out illegal or harmful speech or harmful content, like hate speech. And it's good to know that hate speech detection 5 years ago, based on those models, were 25%. And after bringing transformer models to the world of AI, it increased actually to 95%. So now we are able to detect hate speech by 95% accuracy, which is interesting. So there is a general fear these days, as you all hear about AI is dangerous, and there are some arguments like that it can damage democracy by disinformation and all those things that you heard. But AI actually is the solution for all of that. As you can see, as an example, the hate speech thing. So the beauty of that is we can use AI for the issues that we think AI made. But it's actually the side effect of any technology. It's not just AI. And for AI, we can use it against that issues to actually fix it. So in other domains as well, in education, we have promising progress for as you can see, the personalized education, personalized tutoring, and language learning as well. In physics, for physics of disordered systems, also in larger scale simulations. For example, analyzing particle physics experiments or accelerating the complex simulations, such as fluids or aerodynamics and so on. In chemistry domain, it helps for finding new compounds. In material science, AI helps predicting new material properties, designing the new metamaterials as well. And also in energy storage, it's helpful. So basically, AI enable people generating the creative art in the art domain as well. You are familiar with the image generation models, and I showed you already some of that. So it gives the people who are not very skilled for art to be able to produce art and use their creation for producing art. All right, so now that you know about all of these opportunities, let's talk about a little bit about the risks of AI. Risks of AI can happen in different layers or different levels. The first layer perhaps is data level. So basically the vendor risk is one of the basic ones. So incorporating third-party AI solutions can pose challenges, as you know, as data is often shared with the vendors. that you might not know because it's third party, but it's raising concern about data security and privacy. So there are some ways to handle it, like not accepting the cookies of the website or so on, but usually normal people doesn't know about these things. So what we need to do is strategizing about that and make the companies more responsible about making the terms and conditions more public and more clear. The second one is security risks. AI systems can be vulnerable to cyber attacks, as you know, and unauthorized access as well. So protecting data storage against potential security breaches is crucial to prevent data leaks and other cyber security attacks. About the privacy risks, you know that the vast amount of data is collected or can be collected by AI models, and especially for generative AI, many people put through some sensitive data through like ChatGPT or other tools, and without being aware of that, they are giving away their private information, critical information sometimes. So we need more education around that for using those tools for people as well to manage these privacy risks. And the IP leak is another serious concern. Basically, using generative AI, adding the ease of use of web and app-based AI tools, it brings this risk that creating another form of shadow IT for us. And given that these online generative AI apps send the process data over the internet using the VPN, and it can provide extra layer of security if you use VPN for that, if you want to protect your IP. Synthetic data is another one. As I explained, generative AI can actually come up with totally synthetic data, and it can actually lead to misinformation, fake news, or etc. So we need to be careful about that. And of course, AI can be the solution for that to differentiate between those fake news or fake samples and the real ones. Data poisoning is another threat. So basically, malicious actors can manipulate training data to inject false information or biases into AI models, and just compromising their integrity and reliability. And we need to be careful about the models that we see, about the results that we see these days, because if the data is biased, usually the result is not reliable. And about the data storage scalability, AI generates and requires vast amount of data, which can strain existing storage infrastructure. So organizations need to ensure that data storage solutions can actually scale effectively to accommodate AI-generated data. So another risk level is algorithmic level, which is more important, I guess, and it's out of the hands of people. So the previous one was kind of manageable with people who are using AI models, but this one is for developers of AI, right? Manipulation and bias, as I briefly mentioned, AI algorithms can be manipulated to produce biased and unfair results, and it leads to issues of algorithmic bias and discrimination in decision-making processes. So we need to be careful about those. Deepfakes is another one that AI can be used to create convincing deepfake content, and it might lead to many problems for people who actually are involving with that. Challenges in threat detection. So while AI can enhance threat detection, adversaries may also use AI to invade detection and creating a cat and mouse game in cybersecurity as well. Algorithmic bias, I mentioned before, and that it can actually lead to unfair or discriminatory results, which is not desirable. And about the lack of transparency, which is an important issue. Many AI algorithms are very complex to understand, and the companies that develop them, they don't provide any transparent instruction to understand how it works, which should be actually strategized around that, and we need more transparent AI models. Ethical dilemmas as well. AI algorithms may be faced with ethical dilemmas when making decisions that involve human values and moral judgments. It requires careful consideration and ethical frameworks, which at the moment researchers are trying to apply it, but still a long way to go. And that needs to be done fast, actually. So dependency on AI is another threat that we can consider. So as critical infrastructure becomes more reliant on AI, there is a risk of over dependency. So if AI system fails or like compromised, it can actually lead to significant disruption for the whole system. And it needs to be managed. Another one is infrastructure level, that I think I explained actually most of that, so I'm going to skip it. So on the application level, which is more close to our daily life, we see some concerns from people, and perhaps the most popular one is the job replacement that everyone is worried about that. I get lots of questions about that. Basically, I'm going to give you some information about that. Layoff announcement from US-based employers reached more than 80,000 in May, just the last year. A 20% jump from the prior month, and nearly 4 times the level for the same month last year. Of those cuts, actually AI was responsible for only 3,900, or roughly 5% of all jobs lost. And it makes the AI the 7th highest contribution to employment losses. And it's not trivial, but still, it's not very bad compared to the other reasons. So this is especially true for lower skilled workers in the current labor force, and I list some of the potential jobs here and skills that can be affected by progress in AI, like legal functions, as you can see. So common legal forms and documents, including home lease agreements and those things. So the people who were like administrators for those might lose their jobs because ChatGPT can do it easily. Or mid-level writing as well, and basic email as well. So it can be replaced. All right, so the next one, the next threats in application layer is misinformation and social manipulation that I just explained. So AI systems being used in the service of disinformation on the internet, giving them the potential to become a threat to democracy. And basically, people are concerned that it can be a tool of fascism. So from deepfake videos to online bots, manipulating public discourse by spreading the fake news, there is a danger of AI system undermining the social trust, which is important. But the argument of that people is the technology can be actually co-opted by criminals, and it's simply special interest groups. They can actually manipulate that models to go through the results that they want, and manipulate people as well. So as I mentioned before, AI here is not a problem, it's a solution to detect those illegal use, and we can overcome that problem using AI. That kind of makes that problem. Another concern, which is kind of valid, is concentration of power. So if AI is just, if AI technology is just limited with some companies, just limited companies, it's actually can be dangerous because it could exacerbate inequality and limit diversity in AI applications, which is not desirable. So some people are concerned that if we make AI public, it's dangerous, but it's actually the opposite of that. We need to make AI tools public to be accessible for all of people, and to decentralize the power of AI. And the last one is loss of human connection, which is valid. So increasing the reliance on AI-driven communication and interactions could lead to diminished empathy, social skills, and human connections. To preserve the essence of social nature, we must strive to maintain actually the balance of using AI, using technology and mainly AI for human interaction. So that's on us to be careful about making this balance. All right, now I'm going to wrap up my talk with concluding that AI is more a threat or more opportunity. I'm going to clarify some questions that I usually get from people here. They say that AI will reach human level intelligence or not, and it can be dangerous or not. So of course AI will reach human level intelligence one day, but it won't be actually as quick as we think. So I would say at least 10 years, some people say 10 years, but anyway, it's a long way to go. And we will reach perhaps cat level and dog level intelligence before human intelligence. Those systems, the AI systems, will become the repository of all human knowledge, and it's really important that foundations of those systems to be open source, as I mentioned before. So basically, the risks of that human level AI is that, and if we make it like accessible for everyone, it limits the risk. So some people are worried about that and warning governments all around the world to keep AI under lock and key by some arguments that AI is too dangerous and needs to be controlled and not to be publicly accessible for everyone. But those people has already, some of them convinced the UK government to do that, and I'm personally against that because I believe that it's the opposite. So AGI is another term that's generated, and people usually are scared of that. So I'm going to say that AGI is not real because intelligence is multi-dimensional. So it's a collection of skills and ability to learn new skills quickly, and even humans can only accomplish tiny subsets of tasks. So we don't need to worry about AGI at least sometime soon. All right, so continuing that conversation, basically AI integrated robots won't take over the world. So it's kind of like, the argument that people make is when AI is smarter than us, it's dangerous because they can control our lives. But it's not true. It's kind of like in the companies that, we have a manager in the teams and we have workers in the team, right? And so usually we hire smarter people than us to make progress, right? So I'm sure that in many teams in the companies, like the employees are smarter than the manager. But it doesn't mean that they take over all of the tasks, right? So it's kind of like that. As long as we control AI, and we do, we are managing that, there is no reason for being scared of robots or AI robots can take over the world. So about that, so basically, I'm going to say that this may have an effect on society similar to what printing press had like 500 years ago, to be causing a new renaissance by adding intelligence as a commodity to our society. So that's what AI is doing right now. And basically, it's making a human smarter, and it's kind of like a smart assistant for human that is always with him. So we need to embrace that. All right, so I'm going to conclude it with actually the existential danger that I think it's real. So basically, the risk is existential in the philosophical rather than, apocalyptic sense. So AI in its current form can alter the way that people view themselves. And it can actually degrade abilities and experiences that people consider essential to being human. For example, humans are judgment making, we always do this. But in the future, more and more those judgments actually are being automated by AI decisions and algorithms. So as it happens, people will gradually lose the capacity to make these judgments themselves. And the fewer of decisions that they make, the worse they are likely to actually become at making decisions. Or consider, for example, the role of chance in the people's life. Humans value serendipitous encounters and, like coming across a place by accident or visiting people by accident, being drawn into it, and all of these things won't happen if we just rely on AI for making our decisions and handling our life. But the role of algorithmic recommendation engines is, to reduce that kind of serendipity that we have in our life, and we shouldn't let AI to do that, in my opinion. Algorithms are already undermining people's capacity to make judgments and enjoy the serendipitous encounters, and on critical thinking as well. So as a human, we are better off to be aware of that AI has been developed to facilitate our lives and basically facilitate our routine tasks to save us more time to be our genuine self and make our decisions for our life, right? Not the opposite of that. So it's on us to, just avoid being lost with AI, using AI, and overusing AI for every aspect of our lives. I'd like to close my talk with this famous Holloman closing lines by T.S. Eliot, saying this is the way that world ends, not with a bang, but with a whimper. Thank you.